Today we're going to talk about finding complex solutions of quadratic equations. Now, firstly, let's talk graphically. A real solution, remember, is when the graph hits the x-axis. Now, it could just touch the x-axis and maybe bounce off of it, or it could touch it and stop at the x-axis, or it could cross the x-axis. But in any of those cases, whenever it hits the x-axis, it is considered a real solution. So let's take a look at this first graph. This is the graph here of f of x equals 2x squared plus 4x. I've also graphed it on Desmos here. Let me bring that over. As we can see, this hits the x-axis twice. It hits once at -2 and once at x equals 0. So this has two solutions. Now, what would happen if I were to say add 1 at the end? So f of x equals 2x squared plus 4x, but then let's do a plus 1. So everything moved up 1 unit, and I still have two solutions. They're not as nice as before, but there are still two solutions. What happens if I do plus 2? Okay, in this case, it comes down, and then it hits the x-axis, and it bounces up. But it still hits the x-axis. This is one solution. And plus 3, well, in this case, it comes down and then it goes back up, but it doesn't hit the x-axis at all. So I guess there are 0 real solutions. What about for negative 2x squared plus 4x? In this case, there are still two solutions, one at x equals 0, one at x equals 2. If I were to subtract 1 from this, we can see something similar where I still have two solutions. They're not very nice, but again, still solutions. If I subtract 2, it does the same thing, just on the underside of the x-axis, where it comes up, bounces off the x-axis, and goes back down. So there's one solution there. But then if I subtract 3, it goes up, comes back down, but it doesn't hit the x-axis at all. So there's 0 real solutions there. So the question then is, if there are no real solutions, does this mean that there are just no solution? Because oftentimes in math classes, we write just no solution for these types of cases. But could there be imaginary or complex solutions? So the answer is yes. Here's how to find them. One way is to complete the square. Now, we've done this before, earlier sections, earlier math classes, perhaps even two. You may recall that completing the square for the expression x squared plus bx requires adding b over 2 squared to it, resulting in the perfect square trinomial x squared plus bx plus b over 2 squared. The reason that we do this is because the perfect square trinomial that you create here factors to the quantity x plus b over 2 squared. So here's an example. Let's solve x squared minus 2x plus 7 by completing the square. All right, let's begin by rewriting the problem. So we've got x squared minus 2x plus 7. And I'm going to set this equal to 0. And let's subtract 7 from both sides so that we can get these x terms isolated over here. So subtract 7. And this is going to give me x squared minus 2x over here is equal to -7 on the right side. Okay, now once we're at this point, I'm going to take a look at my x terms. And I'm going to say, okay, this is ax squared plus bx. Ax squared plus bx. What I want to do is I want to add b over 2 squared to both sides. Okay, so what does that mean in this case? B is -2. So this is going to be b is negative 2 over 2 squared. So I'm going to add that to both sides, which really this is negative 2 over 2. This is the same as saying negative 1 squared to both sides. So I'm going to take x squared minus 2x, and to this side, I'm going to add negative 1 squared. And over here, this is negative 7, and I'm also going to add to this side negative 1 squared. All right, let's clean this up a little bit. This is going to simplify this to x, and then we've got this is going to be minus, this is 1 squared. I know this because x squared, the way that this factors to, the square root of that is x, and negative 1 squared is going to be plus 1. It's just positive 1 here. So I know the square root of 1 is 1, so that's why I've got this, and I copy this sign over. So this is x minus 1 squared equals. Over here, this will be negative 7 plus negative 1 squared. Negative 1 squared is going to be negative 1 times negative 1, so positive 1. Negative 6 plus positive, negative 7 plus positive 1 equals negative 6. Got ahead of myself a little bit. All right, now take the square root of both sides. Square root and the square, these two will undo each other, leaving just x minus 1 is equal to plus or minus the square root of negative 6. So I'm going to break this up into the square root of negative 1 times the square root of positive 6. Because I know that x minus 1 equals plus or minus, this is I, and then I'll have square root of 6. Now, to solve for x, add 1 to both sides. My final answer is going to be x equals 1 plus or minus I square root of 6. Okay, let's do another one. Let's try to solve 3x squared plus 9x minus 6 by completing the square. Now, when I give you problems like this, you may not always get imaginary or complex solutions. Sometimes you'll still get a real solution. So in this case, that is what's going to happen. So let's try to solve this the same way. 3x squared plus 9x minus 6. I'm going to set that equal to 0. And let's write that here. 3x squared plus 9x minus 6 equals 0. And let's get those x terms by themselves over here. I'm going to add 6 to both sides. So this will be 3x squared plus 9x is equal to 6 over here. Now what I want to do is I want to get x squared by itself. So right now this is 3x squared. So what I'm going to factor out a 3. Okay, so I'm going to factor out this 3. And that's going to leave on the inside here x squared plus 3x equals 6. And the reason I'm going to do that is so that I can get rid of this 3 by dividing both sides by this 3. This will give me x squared plus 3x equals 6 divided by 3 is 2. This is necessary because it helps me find b. b is 3. And remember, I'm going to be adding b over 2 squared to both sides. So in this case, b is 3. This is going to be 3 over 2 squared to both sides. Let's see what happens here. That means that on this side, I'm going to add 3 over 2 squared. And on this side, I'm going to add 3 over 2 squared. All right, this will always factor to a set of parentheses here, a binomial squared. The square root of the first term, x squared, is x. The square root of 3 halves squared, well, that's just 3 halves. And then the sign in the middle, move that over a little bit. The sign in the middle was this plus 3x, so that means that I'm going to have a plus sign in the middle here as well. And this is equal to 2 plus, okay, this is 3 squared, so 9 over 4, because 2 squared is 4. And let's rewrite 2 as something over 4. That will be the same as saying 8 over 4. So x plus 3 halves squared is equal to 8 plus 9 is 17 fourths. At this point, I'm ready to take the square root. Once I've got this isolated here, I'm going to take the square root of both sides, and I'll say the square root of this thing squared, well, square root and the square, those are going to undo each other, leaving just x plus 3 halves is equal to plus or minus, and what I'll do is just leave this as the square root of 17 fourths right now. Okay, last couple of steps here. Subtract 3 halves from both sides. X is equal to negative 3 halves plus or minus, and I can break this up into the square root of 17 on top over the square root of 4 on bottom, but the square root of 4 is 2. So I would accept this answer, negative 3 halves plus or minus the square root of 17 over 2, okay, or you can go one step further and say x equals, since this is a fraction with denominator 2, this is a fraction with denominator 2, we can say negative 3 plus or minus the square root of 17 all over 2. Okay. So sometimes, as we've seen, answers are complex, and I've got 2 of them. Sometimes we've seen answers are real, and I could have 1 or 2. So we need to be able to do a couple of things. One, determine whether my solutions are going to be real or non-real. And then 2, be able to determine how many solutions I should be looking for. Well, luckily, we have a way to do that. The quadratic formula, you may recall, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The part under the square root is called the discriminant. And the discriminant, just that b squared minus 4ac part right here, this tells us how many solutions we will have, as well as whether those solutions are going to be real or non-real. If I ignore everything else and I just look at the discriminant, b squared minus 4ac, if it is greater than 0, or in other words, if the discriminant is positive, I'm going to have 2 real solutions. If the discriminant is equal to 0, then I will have one real solution. And if the discriminant is less than 0, or in other words, negative, then I'm going to have two non-real solutions. So let's do a couple of these. Determine the solutions, okay, for the functions. The first one, I've got 3x squared minus 5x plus 2. So this tells me a equals 3, b equals negative 5, c equals 2. So my discriminant, b squared minus 4ac, this is going to be negative 5 squared minus 4 times a is 3 and c is 2. This is negative 5 squared, so 25, because negative 5 times negative 5, minus 4 times 3 is 12, and then 12 times another 2, that's going to make 24. 25 minus 24, this is a positive 1, which tells me I'm going to have two real solutions. And this is the answer I'm looking for. So if it just asks you to determine the number of solutions and what type of solutions, that's all you have to do. You don't have to solve beyond that. The second one here, determine the number of solutions for 5x squared plus 4x plus 1. I'm going to do the same thing. A equals 5 in this case, b equals 4, and c equals 1. And then I'm going to plug these into the discriminant. So the discriminant is b squared minus 4ac, which for this particular problem reads 4 squared minus 4 times a is 5 and c is 1. 4 squared is 16. Minus 4 times 5 is going to be 20. 20 times 1 is still 20. And 16 minus 20, this is negative 4. Because this is less than 0, it's negative, this will tell me I'm going to have two non-real solutions. But you could go one step further. This is just determining what type of solutions you'll have and how many solutions. We could go one step further by actually finding what these solutions are. So that's what we're going to do here. Let's solve negative 5x squared minus 2x minus 8 using the quadratic formula. Okay, so the quadratic formula again is x equals negative b plus or minus the square root of 4ac all over 2a. And that discriminant part, 4ac, negative b plus or minus, b squared, I forgot in here. Go. B squared minus 4ac. This tells us how many solutions we have, remember. So let's start there. A equals negative 5, B equals negative 2, and C equals negative 8. If I just do the discriminant, B squared minus 4ac, this would be negative 2 squared minus 4 times negative 5 times negative 8. Okay, well, negative 2 squared, that's going to make 4. And then, let's see, 4 times negative 5, that's going to be negative 20. And then negative 20 times 8, let's see, negative 20 times 8 is going to be positive 160. So this is 4 minus 160. 4 minus 160 is negative 156. So I know that I am looking for two non-real solutions because this is negative. Let's plug in the rest here. X equals negative b. If b is negative 2, then negative 2 is going to make a positive 2 here, plus or minus the square root of negative 156 over 2 times a. A is negative 5, so 2 times negative 5 would make negative 10. All right, this can be broken up. The square root of negative 156. This is the same as saying x equals, let's do 2 plus or minus the square root of negative 1 times, so this will make positive 156 here. Positive 156 is divisible by 4. I'm going to use 4 because that's a perfect square. So this is divisible by 4, and when I do that, I'm left with 39. So this negative 1 times 4 times 39 gives us this negative 156. And this is all over negative 10. All right, what does this give us? X equals 2 plus or minus, let's do the square root of 4 first. That's 2. The square root of negative 1 I recognize as our imaginary unit I, and I'm left with the square root of 39. And this is still all over negative 10. Lastly, 2, this 10 here, they're all divisible by 2 since they're all even. So x is equal to 1 plus or minus I square root of 39 over, technically we could do negative 5 first, but if I were to take this negative, put it out to the front and distribute it to the top part, I could do negative 1 here plus or minus negative I, which is the same as saying just plus or minus I, since we're going the other direction too. So in this case though, I'll leave this as it is rather than trying to go a step further and confusing some people here. So we'll stop there and we'll leave this as our solution. Now let's do one more. Let's solve 7x squared plus 2x plus 4 using the quadratic formula. Again, over to the left, let's set up our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And over to the right, we will put in what our discriminant is. This is b squared minus 4ac. Well, what are these? A equals 7, B equals 2, and C equals 4. So this will give me 2 squared minus 4 times A is 7 and C is 4. 2 squared is 4 minus 4 times 7 is going to give me 28, and then times another 4 is going to be 112. 4 minus 112 is negative 108. So again, this, because it's negative, my discriminant's negative, I'm going to have two non-real solutions. That's what I'm looking for. Let's fill in the rest of the quadratic formula. X equals negative b is 2. So negative 2 plus or minus the square root of negative 108. I've already found this. over 2 times a. A is 7, so 2 times 7 is going to be 14. X equals, let's break up this negative 108 here. This is negative 2 plus or minus the square root of negative 1, because this is negative here. That'll leave me with a positive 108. Let's see, 108 is divisible by 36. So times the square root of 36. I'm using 36 because that's a perfect square. And when I divide 108 by 36, I'm left with 3. So we're going to have another square root of 3 here as well. And this is all over this 14. Okay, x equals negative 2 plus or minus. The square root of 36 first is 6. I recognize the square root of negative 1 as our imaginary unit I. This is over, or this is with the square root of 3 here, and then over 14 still. And is there anything else I can do? Sure. This 2, 6, 14, these are all even numbers. So I can go one step more and say x equals negative 1 plus or minus 3i square root of 3 over 7. And those are my two non-real solutions. All right, this will give you another look into imaginary numbers and complex solutions, as well as how to find them using the completing the square as well as the quadratic formula.